What's going on, YouTube? So today what I'm going to be working on, I have a DIY CNC that I built, a 3-axis CNC, as well as a CNC drill press and a regular drill press. And one of the problems I run into is clearing the chips, whether I'm cutting wood, steel, aluminum, getting the chips evacuated out of the hole that you're cutting or milling is critical to extending the tool life and just making everything, make the quality of the cut better, make your tools last longer, they don't dull out as quickly. So what I'm going to do here is build a kind of a pulsed air blowing chip clearing system. I don't want a constant stream of air because that's hard on my compressor, but what I do want is just a pulse of air every second or two, just to kind of clear the chip and then make way for new chips, new cuttings, clear the chip, and then turn the air off, so the air is cycling on and off. Now I could do this with just a relay and a capacitor, but I have a bunch of these DigiSpark clones. My real DigiSparks haven't come in yet, but I have a couple of these little DigiSpark clones, and these are neat. They have six outputs on them, input outputs. I think one or two of the pins are pulse width modulation, and they got the PCB USB machined and built right into it, so you can just plug it into the side of your computer, program it, unplug it, so it makes developing and prototyping very quick. Also too, they're 1 square inch by 1 square inch, so they fit virtually anywhere, and if you have a project that you only need a couple of pins for, this could be a great option, and they're dirt cheap. These clones, I think I paid probably about $10 for 5 or 6 of them. The real DigiSpark ones, I think they're about 10 or 12 bucks a piece. I've used a couple of these, not had too many problems out of them. They are kind of buggy to get them to work initially, where the authentic DigiSpark ones tend to work without any bugs. So you get what you pay for. So what I'm going to be using are one of these little 1 inch by 1 inch DigiSpark 6 output Arduinos, a voltage to pneumatic solenoid, and these come in a couple different configurations. I like these Mac ones, not only because they're in my parts bin, but also too because they can go up to 120 volts. Let me see if I can get that to focus. There we go. So it's down here at the bottom, it says VAC to 120 psi. Now up here it says 24 VDC, so it can run off AC or DC current. This is can go either way, and it's got 3 inlet outlets, and depending on where you put your air in, where you put your output, will depend on if it vents all the air or if it doesn't vent any air when it's not energized, and kind of its behavior once you energize it. So another option would be one of these. I picked these up dirt cheap on eBay too. These have the barbs, whereas the Mac valves have the threads. For me, the threads work better, especially when you're running higher PSI applications. These little barbs tend to pop off. So this is an option if you have it available. But any voltage to pneumatic solenoid will work for this project. So another thing I'm going to be using is these flexible spouts. I forget the exact name of them, but you can pick these up dirt cheap on eBay too, and you can unsnap these couplings and make it any length you want. You can get different ends for it. You can get different nozzles for it. You can get the flat nozzles, the pointed nozzles. So that's what we're going to be using too. So we're going to be programming the little DigiSpark clones with Arduino IDE, and there's several tutorials on getting these DigiSparks to work with the Arduino IDE on YouTube. I can cover a video if enough people request it, but I think anybody who uses them would know how to program them by now. If not, you can look it up on how to do it. So another little fun project I'm working on is this little guy here. This is an Anoyatron which is just a little device that puts out a high frequency beep every few minutes at random intervals. And so this is a fun little project that you can do with one of these little DigiSpark or DigiSpark clones, because you can just put a PCO speaker right on the input and the negative on the terminal, and then on the back side you can put your little LiPo battery. In mine I have a little switch. I still need to finish programming it, but they make awesome little Anoyatrons that you can stick virtually anywhere. You put a magnet on the back, you can stick it in an air duct or behind a cubicle, filing cabinet, whatever you want, or you can just double stick it to wherever you want. And these things draw such low power, if you put a reasonably sized LiPo battery on this thing, it could run for weeks or months. So if you put it in a really good place where somebody can't find it, it could be a funny little joke around the office. So let me get the camera moved and I'll get you put on the Arduino IDE to show you the programming I got, and then I'll go ahead and kind of wire everything together, and I'll be back shortly. Okay, so here's the program I'm going to use. It's a glorified, or not even glorified, version of the Blink program for the AT-Tiny85 or the DigiSpark or DigiSpark clone Arduinos. So all we're going to do is we do our pin mode here, which is where we set up what output we're going to do. I have 3 outputs programmed just for future add-ons that I want to do. And then we do digital write high, which turns a pin on, we delay, and then we digital write low, which turns a pin off, we delay, and then we cycle through it again, and it runs essentially in an infinite loop. So one thing to note about energizing and de-energizing relays is you have to tune your delay on and delay off, because once you energize a coil, the magnetic field has to collapse before the relay will de-energize. So you got to kind of play with these timers to get them to do what you want to do. I've did some tuning off camera, and what I've come up with is a delay of 3,000 seconds after it turns on, which my outputs are reversed, which you'll see in a minute. And then I have a 100 millisecond delay, which is the amount of time that it's actually going to be on, because I'm using the normally open contacts on the relay board, which you'll see in a second. So the output is off for 100 milliseconds, or a tenth of a second, and then it's off for 3 seconds. And I think that's going to be sufficient for what I need, but you can always go in here and adjust this later on if your timing is not what you need it to be, or you need to make adjustments on it. So let me get the camera zoomed out and I'll show you my setup. Okay, got everything assembled and wired. So what I did with this, I wanted it as small as possible. So I went with kind of this dead bug type technique where everything's just kind of stacked on top of each other. So I have my Mac relay down here, and then I hot glued on this little 2 relay Arduino board that runs on 5 volts, because this can be powered directly from the Arduino without adding in any additional components. So I just have my voltage in, voltage out from my DigiSpark clone, and my 5 volts goes into this little 2 relay board, and then I have my 36 volt or my 24 volts that's going to power this relay tied into the common and normally open of the output on the relays. Another great thing about these little DigiSpark and DigiSpark boards is they can run, I believe it's 5 volt to 36 volt. So I can power this with the same 24 volts that I'm going to power the relay with. So this is entirely a self-contained unit. I put 24 volts to it, and everything is here. I don't need to run additional wires or anything else. And if I put this in a little enclosure, it'll look fairly professional, just with the air in, air out. This little white thing here, this is just a muffler. This doesn't need to be here because the way I have this plumbed, there's no air going to be coming out of here, but I have this here to keep any debris from getting inside the housing. Another thing I did, I put the DigiSpark, I hot glued it on top of the relay, and I made the USB portion of it protrude past the relay, so that if I program it in the future, add any additional functions to it, I can take a USB extension cable, which has a female USB on one side, and then just plug it in like that and program it while it's on the machine. I don't need to pull it off and program it, or you know, it makes it easier to get to. So this is with the programming that I showed you earlier on the Arduino IDE with the timers. As you can see, my outputs are reversed because I'm using the normally open contact on this relay. So when the Arduino says the output is on, it's actually off. And it's kind of hard to tell, but the relay down here isn't cycling yet because I'm not feeding it. It's 24 volts. So let me get you zoomed out a little bit. Now we'll turn our power supply on. And now you can hear a louder click. So when this relay energizes, this solenoid also energizes. And let me hook up some air to it. Sorry about that, my air hose knocked my camera over. So I got everything wired up, got it plumbed up to my air compressor. I got about 40 pounds of air coming into the valve, which is probably about as much as I'm going to run through this. On the output side, I got my little flex nozzle here. I have this entire setup. It just has negative and positive 24 volt in. So we'll turn on the power supply. And then every 3 seconds it will pulse for 1/10 of a second just to get me a little bit of air. And with this flex nozzle, I'll be able to put it exactly where I want to on the cutter, on the drill bit, whatever I have. And it'll be able to blow that chip out of the way and then continue on while still conserving air out of my air compressor, so my air compressor's not running all day to feed this thing. So that's it for my little project. I'll probably throw another one together when it's mounted on my drill press, and then when I make another one of these and mount it on my DIY CNC, and then I'll show it in action. We'll see you next time.